Okay, what you see on the screen is my laboratory with the immersive speaker setup. It's called Auro 3D. There are 5 loudspeakers on the bottom, 4 in the corners, and 1 top speaker over the head. So I really skip my presentation. I will give you a short glimpse just for later, if there is a reference on it. So what we did in between 2003 and 2008 was we tried to optimize methods which are used in acoustical research and for the purpose of artificial reverb. As I told you already, my background was is algorithmic reverb, and I wanted to check the nature. How is the nature is doing? And the method, you asked me to introduce shortly the method. The method is actually you simulate a room by measuring and what I call an acoustical fingerprint. So, and one of your questions is how to get it immersed. To get it immersed, you use a kind of a multi-channel microphone array. That's a simple question. We saw just the solution of Angelo with the Tetra mic. In professional audio engineering, we have a very a big spectrum of solutions for multi-channel. I will not go into that. So after this, you don't need the empty room again. You can use that fingerprint in the studio to create a virtual room. And I will skip that. So the goal was an acoustic instant camera, exactly what you are behind currently. The blueprint, yeah, we wanted to optimize the signal to noise performance, of course. That's why you're behind. Distortion free. There was the solution of having a long sweep to get rid of the distortion of the speaker system, because in the air, the speaker is the weakest thing in the chain. So you should concentrate on the speaker, what we already discussed. I want to be flexible for artistic reasons. Most importantly, it was at that time, 2003, I was behind 5.1 system. Now in my later research, I expanded to Dolby Atmos and Auro 3D systems. A little bit also in binaural, but we can use binaural synthesizers. I'm sure Angelo talks about this later. So there is a possibility to make out of one microphone or stereo microphone complete immersive simulation later. So very interesting is also the subjective part, what Søren talked about. So how can we say this room is perceived well? We have to make listening tests. So my research did include a lot of listening tests with people. What did they perceived well? And then we changed things like microphone arrays, and asked for the best thing. I will not go into the detail of that. But it is important, maybe in your research also, to make listening tests. I'm not sure about your timeline, but never underestimate the subjective factor in that, because art is about human beings and they all perceive it different. Yeah, I don't talk about the measurement signal. That's a big issue. We use that spider microphone, and I use it for a special reason, because for the perception of a natural room, there is an optimal decorrelation, and I cannot get good decorrelation out of a microphone array which is too near. So I need a big spacing for having a concert hall environment, a big envelopment, and for that I prefer widely scaled, and this depends, is it a cardioid microphone or an omni microphone? I understood that hydrophones are always omni, though you should select a big difference to have a good decorrelated answer on that. So we compared localization diagrams. This was how we worked to get this. Is a famous room in Berlin. And what I did, I went to the room with this multi-microphone array. I made 5 locations around the array with a very good speaker, phase compensated studio grade speaker, professional sound studio speaker. And we wanted to simulate the directivity of the source also. So we had to turn this cardioid speaker into up to 6 directions. And all this, to handle all this, we made a software which was called HDIR Creator. And we handed out this software to other partners, for instance, the McGill University, other also commercial partners like Hans Zimmer's company, to make their own, because a reverb can be a corporate identity, a CI. So that's actually the purpose of this. So we had one fingerprint consists of 150 channels in our case. That the musician has flexibility later to have different things, different parameters. Because convolution reverb, they say in the old times, it's not flexible enough, and we try to improve the flexibility for our customers. This is the test signal. What I said is very important, the test signal. Spend a lot of time in finding the right test signal, because there is distortion from the box, and this is the sweep, and the backwards processing, the convolution with the inverse filter, brings you, only if you have a long sweep, which is about double the time of the reverberation time, and then you can cut off the distortion. These are the phantom things here. You can cut them off. So in order to create an idea, also spend a lot of time in post-processing it. I developed methods to post-process. I can compensate for a certain degree the deficiencies of the measurement speakers, of course, by compensating that in the C1 thing, and the deficiencies of the microphone in the C2 filter. And by comparing them, I can cut it. And to make the thing short, I work up to 1 or 2 weeks in the post-pro of IR before I give it to the artist. So I don't want to get, this is the software I did, so interested parties can get that software. This is the main result of all my research is that the speaker type is very, very, very important, because we want to simulate the room and not the speaker. But if you use a convolution reverb, it sounds always as an orchestra playing through a speaker to the room, to my ear. And I don't want to hear the speaker. I want to hear the orchestra. So the speaker has to be transparent, completely has to go away. And you have to find a solution for that. In that time, 2005, we had a selection of several speakers, and we ended up having the best studio speaker, what we could achieve and what we could get in the bucket. We showed here that our auralized solution is the same as you stand under the shower. In the forest, it's important maybe also for you to know the point where you record was in a forest, completely different. You go 5 meters away and it sounded different. So what we did with our team, always with several persons, one guy was clapping in the hand and the other guy was searching a point to listen. So we simulated always the best point to make the sound and to capture the sound. And I think underwater, it's similar that not all points are the same in a fjord or somewhere. So you have to search for the point. Normally, if I make a good capture of a hall, I need a full day in the hall. 4 hours minimum, 8 hours normally. Yeah, I don't want to check this. We found a church in Berlin where the Deutsche Grammophon worked. So we concentrated on concert halls. And we have this program out. And in the end, it runs on a hardware. 2003, the Convolver was a hardware made by the Swiss company Wise. And Hans Zimmer's company we made a library, and you could license this library as a manufacturer of reverb. Let me conclude with one point here. This curve is very important. Do you see this curve? Yeah, I don't hear you, strange.
Yes, we see it. Sorry.
Okay, good. This curve is a German standard, DIN standard for medium and small sized rooms for music production. So because yeah, what should be the target shape of your reverb, that it is perceived as a great reverb for music? And the German Standard Committee had a task force, and they decided, okay, we make some recommendations, and they have this thing for concert halls. So they have for huge concert hall 2.1, large concert hall 1.8, and actually it's the mystery of a good acoustician. What is his target curve? The target curve is really like in the old times the company mystery. Nobody tells you what is the best curve. Everybody has his tricks. For instance, some love to have a dip here, that it's shaped like an S with a dip here. So it's a big discussion among the experts. What is the best target curve for a reverb that is perceived as good? I show you here a little bit a concert hall, which you see the frequency of the impulse response. And I can, if I move this slider, you see that the treble goes faster to 0 than the mid, than the bass. But in general, it's very flat here. So this is considered as a very good concert hall. And this flatness is I think, your challenge underwater. So until you don't reach this flatness, you always hear some comping stuff, and the comping is very easy to hear. I will show you a little bit. Give me a second. Where is this?
That's great, Ralph. That's great. Really, thank you. That's if it's okay with you, I would build upon your
yes.
presentation.
It's only 1 minute for the very last thing, that we have this plugin out. What is a 150 channel convolver for a PC? So you in this plugin, which is an environment plugin. So I can I have here your examples already in. So you can have your reverb, and even the speaker you can simulate, and your voice. And you can put that in a forest. So with this engine, you can have a complete environment simulation. That's my last point for today.
Great. Thank you very much, Ralph. That was lovely.
It's going to be interesting to put hands on it.
You are invited to learn more about this by just Skyping me and stuff.
We really need to talk, Ralph.
Okay.
So I just want to thank you, Ralph, and I want to ask Bjorn to continue this, let's say, more technical, if you can call it that, or acoustic technology discussion with his 3D system. So Bjorn, you have the word.